Welcome to Schneer Elektrostatik GmbH. My name is Olaf Schneer. I am General Manager. And today I would like to talk about high-voltage generators, especially in atomizers for wet painting. Again and again the question, what should I use? A high-voltage generator integrated into the atomizer, or an external high-voltage generator? I would like to briefly discuss the advantages and disadvantages. I have brought along 3 different high-voltage supplies. Firstly, an older model for integration into the atomizer, the cascade, and then the high-voltage control system. In this case, a control system that we developed and built for FANUC, or are still building. Then, on the other side, the very latest high-voltage generators, which are external. Our Smarty 310 series. And then something completely new. Namely a miniaturized high-voltage generator that already has an integrated controller. Yes, integrated control, that's the keyword. That was actually such a big step between this generation. The cascades here were also external, that is not integrated in the atomizer, but still controlled via high-voltage controller. And for more than 13 years now, we have integrated the complete microelectronics into the high-voltage generator. This means that I only need 24 volts and a bus system. This high-voltage generator can then be attached to the robot elbow in the paint shop, and then supply the atomizer with high voltage via 2-meter cable. In this case, the cascade would be integrated into the rotary atomizer. And this now has advantages and disadvantages. So the advantage of the integrated high-voltage supply is that we don't have a high-voltage cable that we have to lay. We have a smaller capacity, and we have a relatively simple installation. However, there is one limitation, and that is with the integrated high-voltage generator into the atomizer. I'm bringing earth potential into the atomizer, and that can cause problems under certain circumstances. Cause problems. Normally, everything in the rotary atomizer is grounded, that is the turbine, bell disc, and so on, is all at high voltage potential. This means, of course, that I have to take special insulation measures. So maybe that's a limitation to the simple installation. And that would also be a disadvantage that I can see, because we simply bring the earth potential relatively close to the high voltage potential. And that could become a problem with leakage currents. What are the advantages of an external high voltage generator? First of all, we don't have any earth potential within reach of the atomizer, because I drive into the atomizer with a high-voltage cable. Then we have extremely good control, because we have the electronics directly on the high-voltage generator in this area. This means that we don't have any cable runs in between that could have a negative impact on the regulation. In our experience, we can achieve significantly better control here, and also an excellent spark detection, which is not so easy with the other system. A huge advantage, probably even the biggest advantage of a system like this one, is that we were able to realize redundant measuring resistors here. This means that the entire high voltage measurement is redundant, then goes to a safety relay, and we can report back here with a performance level. I am safely discharged. So safely discharged that I can even touch the atomizer with a flammable cleaning agent and clean it that is below the ignition limit, and with a performance level, which means that a door interlock can be implemented relatively easily. We can solve this problem so easily here, because the integrated high-voltage cascades usually don't fit redundant high-voltage measurement in the integrated high-voltage cascades, simply because of the space available, and a safety relay does not fit in twice. This of course means that the user or the system manufacturer has to make a much greater effort to implement the safety concept. We are now a bit in between here. This is now our smallest high-voltage generator that already has integrated electronics. Here we have implemented the complete control electronics and a CAN bus system in a miniaturized space. This means that we actually have the advantages of fast, clean control here. But we cannot achieve this redundant measurement. So what are the advantages of a high-voltage generator in the atomizer? Justified question. Personally, I'm not a big fan of the integrated cascades because the vulnerability, insulation distances, etc. If the installation is not done properly, if there is moisture or dirt on it, then that can lead to problems. And no matter how, even if we integrate the high-voltage generator into the atomizer, we are still in the ignitable range. Because if we want to be outside the ignitable range, then we have to comply with 0.24 millijoule. According to the current version of the N50176 standard, this means a Type L system, which will probably be called L1 in the new standards in future. And that means we would then have a discharge energy of less than 0.24 millijoule. But we can't achieve that. Because in order to maintain 0.24 millijoule at approx 80 kV, we have to be in the 0 decimal point picofarad range, and the turbine plus the bell cup alone of such an atomizer, that is the naked atomizer without cascade, without high voltage cable, is already in the range of 15 to 25 picofarad. This means that even without a cascade, an atomizer would be ignitable if it is charged with high voltage. So we do not achieve ignition protection here. What we might achieve, if we really install a very, very small cascade and everything is super insulated, we might achieve a Type BL still of the current version in the future standards, probably called L2. And that means we would have an ignition hazard. We are above 0.24 millijoule. But we have no danger to people. And the danger to people is also a double-edged sword, because number one, if I'm under 350 millijoule, that doesn't mean that we can't get extremely unpleasant electric shocks, and it also doesn't mean that a sensitive person might jump backwards and then injure themselves. But now there is something even more critical, because we always have to assume that we are cleaning with flammable cleaning agents on paint shops. This means that the person goes into the system with the solvent and then cleans, which means that we have to comply with the ignition protection again. And we can never do that with a system like this. As I said, we are always in the range of a few 100 millijoule to perhaps even in the Type CL range, depending on the capacity, that is over 350 millijoule. If we now take the system here, then we have a capacitance of 120 pF somewhere in the cascade. Then there is also a high voltage cable, 2 meters, plus perhaps another 100 pF, plus the 15 to 25 pF from the atomizer. Which means that with 80 to 90 kV, we are definitely in the range of over 350 millijoule. And we can't do it with such a system. In the range above 350 mJ, and then we will automatically be using either a CL system, or a DL system. In future, the two classes will probably be combined into L3 types. So, the distinction between CL and DL types in the standard was actually only about to flame retardant coating agents and normal flammable coating agents. This means that whether I am above 2 joules or below 2 joules will no longer play a major role in future. This means that we are actually always in the flammable range for all systems. And then I have to take all protective measures. This means that the last advantage I might have with system is that the discharge time is somewhat shorter. This means that if I switch off the high voltage, I can discharge a little faster, which we partially compensate for here through the redundant measurement. We have two discharge resistors, so the measuring resistors are also discharge resistors, and therefore also discharge faster. And here we still have a very big advantage, because there is also this variant with a discharger. And how to use a discharger, there is a separate video about it. Then we are discharged within less than a second, so much faster than with such a system. To summarize from my side, I don't see any great advantage in integrating a high-voltage generator in the atomizer. But of course we also offer such systems because it's also a bit of a question of philosophy. We are not saying that this is wrong or that it shouldn't be done. However, we see the greater advantage of an external high-voltage generator mounted on the robot, and thus to be able to implement this performance level D with redundant measurement. As I said, this is our brief view of the high-voltage generator, and I hope it was informative. Subscribe to our channel if it was exciting, and I look forward to the next video.